Okay. Oops. There we go. We are going to be on this section, 2.7, and we're going to talk about the inverse of functions now. So we spent some time in the last section going over how to work with functions by adding them, subtracting them, multiplying, and then we also did talk about doing the composition of functions, which is what we just did on the bell ringer, where you're taking one equation, plugging it into the x on the other equation. Something else that we can do with functions, though, is find the inverse of them or be given two functions and be able to decide if they are inverses of each other. We'll also talk about how to look at a graph and decide if it has an inverse or not, and then how we could maybe graph that quickly, not having to spend a lot of time creating a whole set of points and stuff. We can just use what we know from the graph, use that information to help us graph the inverse, if it has one. So the first thing we're going to talk about is, can you decide if two functions have an inverse of each other or not? So we're going to kind of continue to do those composition of functions that we did in the last section, where you're taking an equation and you're plugging it into another equation. When we do this, though, when you plug them in to each other, they both need to come out so that it equals x. So when you plug g's into f's equation and you simplify it, you want your final result to just say x. And when you go the other direction, you put f into g, you want to simplify it, you should just end at x. If you end with an x, that is telling you that they are inverse functions of each other. If you get anything other than an x, so if it says 2x or even x plus 1 or something like that, then it's a no. It has to equal x at the very end in order for us to say yes, they're inverses. Okay, so we're going to practice this here. We have these two functions, f and g, down below, and we're just trying to decide if they're inverses of each other or not. And so we're going to do that by doing that composition practice that we did in the last section. So I'm going to start by doing f of g. So this would be when I take g's equation and I'm going to plug it in for the x on f's. So I'm taking this whole fraction here, I'm going to put it into the x over here. So I bring down that 4, and then instead of an x, I'm going to plug in that fraction, x plus 7 over 4. Close the parentheses, and then I still have minus 7 from my f's equation. What is going to happen when I distribute there?
Won't the 4s cancel out?
The 4s are going to cancel off. And what am I going to be left with when that happens? X plus 7 minus 7. So what do I end with here? Just x, right? So that's positive because remember I said when we do this, we want it to equal x. It is important, though, that you check the other side. So just because you get one x doesn't mean you're guaranteed to get an x on the other half when you do the second composition. So we do have to check both. So now we're going to switch it around and we're going to do g of f. So now we're going to take f's function and we're going to plug that in for the x over here. So up on top of g's function, it says x plus 7, but instead of writing x, we're going to replace that with 4x minus 7. So that goes in for the x, and then we still have left from g's equation plus 7 all over 4. Can you start simplifying? So you're seeing that this 4 is going to cancel here. Is that what you're talking about? Because what happens with the 7s? They're gone. And so really, yeah, you're left with this 4x over 4. And so it's true, those 4s are going to cancel. What are you left with? X. So since I got x on both of them, that means that they're inverses. So I can say yes. Again, they both have to say x. So you do need to check them both. You can't just do one and get an x and think that the other half's going to work out because it may not. So you have to check both. And if you get anything other than an x, it's a no. Okay, questions on how we did that? Okay, if you guys go to the next page. The next thing we're going to talk about is how would you find the inverse of a function? So not necessarily given two that we're trying to decide if they are inverses of each other, but we're just given one equation and we want to find the inverse of it. You've done this in Algebra 2. We did this process. You also did it when you were in Algebra 1. So some of this is going to hopefully feel a little bit like review. But when you find the inverse, your first step is to replace your f of x with a y. So let's just kind of work through this problem as we go through the steps up above. So down here it says f of x equals 2x plus 7. I'm going to replace f of x with y. Because remember, f of x really means y. It's just a fancy way of writing that. So I'm going to rewrite this so it says y equals 2x plus 7. That takes care of step 1. Okay, step 2 says to interchange x and y. So you just take your variables and they just swap positions in the problem. So this is step 1. Step 2 is I'm going to write x equals 2y plus 7. Okay, step 3, and this is probably where the majority of the problem is going to happen. You have to now resolve this equation for the y. So I'm going to bring it up here where I have a little bit more space for step 3. I have this equation, x equals 2y plus 7. How would you guys start to get y by itself here? Minus the 7. And then, yes, we're going to divide by 2. And we're going to do that on both sides. And I'm just going to put that whole thing, x minus 7 over 2. And so these are gone. And so I have this x minus 7 all over 2 equals my y. Now that I have y by itself, I'm ready to go on to the last step. So I did step 3. Last step says check your work, but I would probably say the only thing I'm going to want to see you do at the end, so for step 4, is instead of writing it as y, I want to go back to my function notation. If you remember, though, when we did this in Algebra 2, we don't just say f of x again. We say f prime of x because we're saying that this is now a new equation. It's not the same as the one that we started with. And then it would still just be x minus 7 all over 2. So this right here would be your final answer. So that equation is the inverse of that 2x plus 7. Does that feel familiar to you guys?
Do you have to have like that one in between?
The little dash?
Yep.
Yeah, we have to have that dash in there. Or if you said like g of x instead, if you switch that first letter, that would be another way you could write it. But if you're going to keep the same letter f, we do need to see that little dash. That just notates that it's new. Just like in geometry when you guys were doing like transformations and that, you would say like ABC and then you would say A prime, B prime, C prime. It's the same idea. Okay, questions on doing that? Like I said, hopefully that felt a little familiar because I know we did that just last year in Algebra 2. All right, now we're going to kind of switch into the graph part. If you guys remember, we had something called the vertical line test, and that was used to determine if something was a function or not. So if you have a graph and you were able to draw a vertical line through it and it only hit the graph one time, that told you that it was a function. Okay? We have a different test that we can use to determine if something has an inverse. We can use the horizontal line test to decide if something has an inverse or not. Okay? If you draw a horizontal line through your equation and it hits one time, then that means it would have an inverse that we could find out there. If it goes through more than once, then we're not able to find the inverse. Okay, so for example, on that first one, it's one of those V graphs. That's an absolute value graph, remember. They drew in this horizontal line right here, and it hits here and here on the graph. It hits 2 different spots. So that means there's not going to be an inverse function. If you guys look down at the second one, if we draw a horizontal line, how many times does that hit?
Once.
Just once, right here. So this would mean, yes, it has an inverse. So vertical lines help us figure out if something is a function. Vertical or horizontal lines help us understand if it has an inverse or not. Okay, so now let's look at when we have something on the graph, how we would figure out how to graph the inverse. And like I said, I'm going to show you a really simple, quick way to do this that does not require a ton of hard thinking. It doesn't require you to use a calculator. It doesn't require you to create like a whole new table of values. When we are comparing an original function to its inverse, when we started that problem out, back on the previous page, and we were trying to find the inverse, what was step number 2 that we had to do? After we switched f of x to y, what was step 2?
We switched the x and the y.
We switched the x and the y around. So when you're looking at a table of values from a function to its inverse, the x and the y values are just going to switch around. So I want you guys to look at this equation here, or this graph. Let's name these points, like coordinate-wise. So starting on the far right side there, this point right here, how would you name that as a coordinate?
4.
4, 1. So I'm just going to write that right next to it. This is 4, 1. Okay, kind of going along the line up there into that quadrant 2, what's that point? Good, -2, comma 2, and then what's this last point down here?
3, -2.
To graph the inverse, guys, you're going to take those coordinates, you're going to just do a little switcheroo with the x and the y, and that's going to be your new point. So my first point over here was 4, 1. I'm going to switch that to 1, 4, and I'm going to graph that point. So I'm going to go over 1 and up 4. This is going to be my inverse. So if I go to -2, 2, what would my new coordinate say? 2, -2. And then what would that last one do? -2, -3. Then we just connect. And there's your new graph. Not too bad. Okay, you just have to find easy points that you can identify. Switch those coordinates. That gives you the new points for your inverse function. The other thing, I'll just point this out. If I were to draw in the line y equals x, that would be the line that goes through the origin, and it goes up 1 over 1, like it has a slope of 1 over 1. This would be the line y equals x. That line should be acting like a line of reflection. So my original function up here is kind of that red line, and the green one, those points should be the same distance away from that red dotted line that I just drew in. So like this coordinate here, 1, 4, should be the same distance away that 4, 1 is. It's reflecting over that line. That's truly what's going on here when we think about finding an inverse, is we're doing a reflection. And that happens with all of these. -2, 2, 2, -2, and then -3, -2, -2, -3. They're all the same distance away from that red line. So you don't need to be including that information in on your graphs. I just wanted to talk about that. That should be happening. You should see that they're like mirror images of each other. They're flipping back and forth. Okay, so let's do this last one. Let's find a couple of easy points to read. What are some points that you guys can grab off of that red line? 1 or 0, 1, right? Is there another one that would maybe be easy to read? 1, 2, and maybe even 2, 4. Okay, so let's graph the inverse. What would be the inverse of 0, 1? 1, 0. Inverse of 1, 2? 2, 1, so you go over 2, up 1. And the inverse of 2, 4 would be 4, 2. Now kind of just notice the trend of this graph, the one in red that we started with. Notice how it kind of approaches that y-axis, but it doesn't ever really seem to appear to cross it. We'll have to keep that in mind when we draw these points in. So it's still going to have like this curved shape to it. So it's going to kind of go up this direction. But as it comes down, it's probably going to approach the y-axis but not actually cross that. It's going to, again, mirror that red graph that we had. So I'm reflecting it over that imaginary line that's still right here. And so it should just kind of flip over that line and make a matching image. Questions on how to do that? Okay, that's it for today.